Hey guys, it's Malina again, and today I want us to look at yet another economics assignment problem and a solution. And the question is, we take the Matsuyama model and want to compute the effect of inequality. We assume labor endowment Y is distributed uniformly over by Y minus sigma by Y plus sigma into brackets. Unit labor requirement in the first sector is A0. Unit labor requirement in the industrial sector, good one, is A into bracket Q1 into Q1. A is less than 0, where Q1 is total output of good 1. Show that the equilibrium steady state level of Q1 must satisfy Q1 is equals to half minus A0 minus bar Y plus A into brackets Q1 over 2 sigma. Show that an equilibrium is stable if and only if A into brackets Q1 is less than 0 locally. What is the effect of A0 and bar Y on Q1? Explain. Show that an increase in income dispersion sigma may increase or reduce output depending on whether or not the average agent can afford the industrial good. What is the typical path followed by output as sigma increases? Assume now that there is a second industrial good, good 2, with the same hierarchical preferences as the Matsuyama paper. How is its outputs determined in steady state? How does inequality affect it? Does inequality always affect the output of each industrial good in the same way? Now let's look at the solution. The differential equation in the case of good 1 is Q1 is equals to phi 1 into brackets Q1, where phi 1 into brackets Q1 is equals to delta 1 into brackets 1 F into brackets A0 plus A into brackets Q1 minus Q1. Here we are given a specific distribution. F into brackets X is equals to minimum into brackets maximum into brackets X minus bar Y minus del minus sigma into brackets in over 2 sigma 0 into brackets 1 into brackets. And so the condition for the steady state is Q1 is equals to 1 minus minimum into brackets maximum into brackets A0 plus A into brackets Q1 minus bar Y minus sigma over 2 sigma into 0 into brackets 1. If A0 plus A into brackets 1 is less than bar Y minus sigma, then Q1 is equals to 1 is a steady state. If cumulative output is equal to 1, then productivity is sufficiently high such that everybody can afford to buy the good. This steady state is also stable. For Q1 slightly below 1, we have Q1 is greater than 0. If A0 plus A into bracket 0 is greater than bar Y minus sigma, then Q1 is equals to 0 is a steady state with no cumulative outputs. Productivity is so low that nobody can afford to buy the good. If A0 plus A into brackets Q1 into brackets bar Y minus sigma bar Y plus sigma, then Q1 is a steady state. If Q1 is equal to half minus A0 plus A into brackets Q1 minus bar Y over 2 sigma. We already discussed stability for the corner solution, so let's focus on the stability of possible steady states with A0 plus A into brackets Q1 into brackets bar y minus sigma bar y plus sigma into brackets. Stability requires that a small increase in Q1 makes phi into brackets Q1 negative, and that's a small decrease, and that a small decrease makes it positive. This leads to the condition A into brackets Q1 is greater than 2 sigma. It is clear that the condition A1 Q1 is less than 0 is a typo, both in terms of the sign of the inequality and the right-hand side. The destabilizing force is that an increase in cumulative output increases productivity, which increases demand, which in turn increases cumulative output. For a steady state to be stable, this force cannot be too strong. This force is weaker if A into brackets Q1 is not too negative, because then an increase in cumulative output does not reduce productivity that much. The force is also weaker if sigma is large, because then a given reduction in productivity does not increase demand very much. From now on, let's focus on the interesting case in which A0 plus Q1 into multiplied by A about bar y minus sigma bar y plus sigma into brackets, and in which the stability condition is satisfied. Implicit differentiation yields partial derivative of Q1 with respect to A0 equals negative 1 out over 2 theta plus A into brackets Q1. Making food more difficult to produce reduces steady state cumulative output of good 1. Now we get partial derivative of Q1 with respect to sigma equals 1 over 2 sigma plus A into brackets Q1, and A0 plus A into brackets Q1 minus bar y over sigma. Thus, an increase in equality will increase steady state cumulative output if bar y is less than A0 plus A into brackets Q1. That is, if the average agent cannot afford the industrial good. In this case, only the upper tail can afford the industrial good, and increasing inequality puts more mass into the upper tail. If instead bar y is greater than A0 plus A into brackets Q1, then only the lower tail cannot afford the industrial good. Now, increasing inequality increases the number of people unable to afford the industrial good by putting more mass in the lower tail. I guess here one may want to distinguish between cumulative output and output. You see, in steady state, they are the same, but they can be different during the transition. And the path of output is perhaps more interesting. Suppose we are in the situation where an increase in equality increases the steady state level of cumulative output. Of course, cumulative output cannot jump and will converge gradually to the new steady state. However, output will jump up immediately as more people can buy the industrial good, and continues to increase during the transition as the production of the industrial good becomes cheaper as time passes. The analogous steady state condition for the second industrial good is Q2 is equals to a half minus A0 plus A1 into brackets Q1 plus A2 into brackets Q2 minus bar y over 2 sigma. An implicit differentiation yields partial derivative of Q2 with respect to sigma is equals to A0 plus A into brackets Q2 plus A2 into brackets Q2 minus bar y over sigma minus A1 into brackets Q1 partial derivative of Q1 with respect to sigma over 2 sigma plus A1 into brackets Q1, and substituting our earlier result gives a partial derivative of Q2 with respect to sigma equals A0 plus A into brackets Q2 plus A2 into brackets Q2 minus bar Y over sigma minus A1 into brackets Q1 1 over 2 sigma plus A1 into brackets Q1 A0 plus A1 into brackets Q1 minus bar Y over sigma all over 2 sigma plus AY into brackets Q1. If bar Y is less than or equal to A0 plus A1 into brackets Q1, then inequality clearly increases output of the second industrial good. Holding Q1 constant, the same logic as in the previous part applies, and the increase in Q1 goes in the same direction. That means the logic is the same as that of a fall in A0. If bar Y is greater than or equal to A0 plus A1 into brackets Q1 plus A into brackets Q2, then inequality clearly reduces output. It's now both effects are reversed, but the effect is ambiguous for intermediate values of bar Y. The direct effect of the increase in inequality is positive, but the fall in Q1 works in the opposite direction. It could happen that Q2 increases while Q1 falls, so it needs not to be the case that all industrial goods move in the same direction. Now that's the end of the solution. Now, if you're having trouble completing your economics paper and would like someone to help you, just send us an email via info@economicshomeworkhelper.com and we'll do that assignment for you immediately. Thank you.